In the last few years, the tech industry has been upended with the advent of ChatGPT and other large language models. As you probably know already, ChatGPT is a large language model that uses natural language processing to generate human-like text in response to user prompts. It is now possible for machines to have natural sounding conversations with human beings. In fact, machines can now perform tasks like basic reasoning, sentiment analysis, translation, code generation, and so on. This has opened up many exciting possibilities for enterprise business applications. In this course, you will learn the basics of how to work with ChatGPT and build exciting business applications with it. Hello everyone, my name is Varad. I will be your instructor for this course, Building Apps with ChatGPT and Python. About this course. This is an intermediate level course in generative AI. It will teach you how to build Python apps that interact with ChatGPT. It will introduce RAG or RAG, a popular approach to build ChatGPT applications. Then it will describe a business use case for a RAG chatbot and show how to build one using Python. Who is this course for? This course is great for both technical managers and programmers who want to learn about RAG-based chatbots. Coding is optional. A knowledge of Python would be required to follow along with the examples. If you like to code, you will get hands-on experience in building a RAG-driven chatbot. Are there any prerequisites? This course assumes a basic knowledge of programming in Python and ChatGPT, but don't worry, the examples are quite simple and easy to understand. I will explain the difficult concepts as and when we encounter them. In fact, there is also a section where I introduce ChatGPT, the very basics of it from the console. Learning outcomes. In this course, we will be introducing ChatGPT, the ChatGPT API, building a ChatGPT app using Python and OpenAI APIs, discussing about RAG style architecture, and building a RAG-based app with ChatGPT. Before I go on, let me briefly introduce myself. I am a CXO level advisor, architect, product manager, and instructor. I run a company that helps clients harness the power of AI and machine learning to create value, optimize performance, and drive innovation in their businesses. I have spent over 3 decades in technology management and consulting with software, cloud, and SaaS leaders. I have conducted corporate training on various technology topics. I was a Gen AI champion at Amazon Web Services. I am an active blogger and have written a book introducing AI to managers and non-technical users. I am an AWS AI machine learning specialist and a deep learning certified specialist from Coursera. I have master's degrees in computer science and business administration. So that's about me. Module 2, Installing the Prerequisites. Trying out the demos yourself. From here on in this lecture, you could either follow along with our demos or try out the code yourself. If you would like to try the code yourself, you will need to set up Python in your computer and obtain an API key from OpenAI, the company that developed ChatGPT. This is explained in the following slides. Installing Python and pip. First, you need to install Python and pip if you have not already done that. The instructions on how to do this on the Mac and on Windows is given below. This course was developed using Python version 3.12. Getting an API key for OpenAI. To communicate securely with OpenAI, your app will need an API key. This can be set up as follows. First, create an OpenAI account. Go to the OpenAI website and sign up for a new account if you don't already have one. Access the API section. Once logged in, navigate to the API section within your account dashboard. Generate a new API key. Click on Create New Secret Key to generate a unique API key. Copy and store the key. Carefully copy the generated API key and store it securely. A note about pricing. Before we go on, let us understand how much an API call to ChatGPT will cost. Pricing for all large language models is based on the number of input and output tokens. You can think of tokens as pieces of words, where 1000 tokens is about 750 words. Below is a picture that explains how the pricing would work. Note that the total cost is based on the sum of both the input and output tokens. And here the numbers are expressed in millions of tokens. You can get a detailed view of the prices charged by various ChatGPT models on the OpenAI website. Purchase credits. To test the API, you will need to add payment details and purchase at least $5 worth of credits. This allows for a pay-as-you-go system, so you only pay for what you use. You can test basic features of OpenAI's models without writing your own API code using the OpenAI Playground. This is a no-code environment where you can experiment with models like GPT-4, GPT 3.5, 4.0 and others. You can test out all the examples in this course with a one-time purchase of $5 in credits from the OpenAI website. In fact, it should cost you much less than that, but $5 is the minimum you will need to get started on the website. The next few slides describe how to set up an API key at the OpenAI website. First, you visit openai.com and scroll down and click on the link for API login, as shown in the screen here. Then you create an account. You sign up on this website by creating a username and password. Next, you set up a payment method and add some credits. Start with a low amount such as $5. Next, you visit the API keys section shown on the left panel and create a secret key and download it. Store that secret key securely in a place in the laptop somewhere. Next, you can review the pricing details. The examples in our course use GPT 3.5 and GPT 4.0. Pricing details for GPT 4.0 are given here. For example, you see that it charges $2.50 for every 1 million of input tokens and $1.25 for every 1 million of input tokens using the batch API. Use an editor for the code samples. For the code samples in this course, feel free to use any editor of your choice. I have used Visual Studio Code that's available for Mac, Windows, and Linux. You can download a copy from the Visual Studio site that is shown here. Module 3: Introducing ChatGPT. What is ChatGPT? ChatGPT stands for Chat Generative Pre-trained Transformer, and it is based on the transformer architecture, which you can read about in other sources. But I assume by now most of you would have heard about ChatGPT and tried out a few examples on your own. It is also known as an LLM, or a large language model, that uses natural language processing to generate human-like text in response to user prompts. If you have not used ChatGPT before, this may be a good time to head over to the ChatGPT website and try out a few examples. Before I go on, let me talk briefly about chatbots before ChatGPT. In the past, programmers created chatbots using an elaborate set of rules and business logic. Take, for example, the interaction below between a chatbot, that is pre-ChatGPT, and a human being. So you probably see the limitation of the chatbot here. It needs an explicit selection of one of the four options because the programmer has coded the logic to handle only one of those four options. So when a customer is asking a general question, if it does not fall within those four options, the chatbot keeps repeating it. And finally, it ends up assigning the call to an agent. To make the chatbot provide more human-like responses, the programmer has to build logic to handle all the possible ways that the customer can make a request. You can see how cumbersome this is. This was one of the big limitations of chatbots prior to ChatGPT. So how is ChatGPT different? ChatGPT belongs to a class of models called large language models, or LLMs. They have a reasoning engine built in. So the programmer does not have to code every outcome explicitly. Once it has been given the high-level instructions, ChatGPT can handle turn-by-turn conversations almost as well as a human being. It is based on a technology called transformers. By the way, GPT stands for Generative Pre-trained Transformer. This is truly one of the greatest achievements of artificial intelligence. The power of ChatGPT and other LLMs. This ability of LLMs to serve as a reasoning engine opens up a host of possibilities for new business applications to be built using them. They can be used to summarize text or generate new text, to translate language, to write code from comments or generate comments from code, generate pictures or interpret what is in a picture, and so on. This makes LLMs ideal to work as customer service chatbots, as knowledge assistants for lawyers, doctors, and so on. And these are just a few of the exciting possibilities. Trying out ChatGPT. In the next few slides, I will go over some simple examples with ChatGPT. If you are already familiar with ChatGPT, feel free to skip the next 10 slides. This is just to introduce you to ChatGPT in case you're not familiar with it. First, visit the website openai.com, log in and go to the playground. On the right, you see a few options. First, you see a place to select the model. Here you can see we have selected GPT-4o. Next, we select the format of the response. Here we have selected text as the format. Let's skip the section on functions for now. In the model configuration section, we have a variable called temperature. It is a slider. Currently, it is set to 1.0. When you set the temperature to 1 in ChatGPT, it generates responses with a normal level of randomness, meaning that it will provide a balanced mix of expected and slightly unexpected answers, striking a middle ground between highly predictable and completely creative outputs. Essentially, this is considered the default setting for most situations where you want a natural and varied response. When you set the temperature on ChatGPT to a value higher than 1, the generated responses will become significantly more creative, diverse, and unpredictable, essentially introducing a higher level of randomness in the model's output, potentially leading to less coherent or even nonsensical answers compared to a standard temperature of 1. When you set the temperature on ChatGPT to less than 1, the generated responses will become more focused, predictable, and less creative, as the model prioritizes choosing the most probable next word, leading to a more conservative and consistent output compared to a higher temperature setting. So you can play around with the temperature and see which one fits your exercise. Next, let's look at max tokens. Max tokens in ChatGPT refers to the maximum number of text units or tokens that the model can process in a single prompt or response, essentially setting a limit on how much text can be included in a conversation before reaching the maximum capacity. For most ChatGPT models, this limit is around 4096 tokens. That is including both the user's prompt and the response from the AI. Stop sequences, as the name indicates, tells ChatGPT to stop generating a response when the stop sequence is reached. The top P in ChatGPT refers to a parameter called top P sampling, which controls how many possible words the model considers when generating text, essentially acting as a threshold for the cumulative probability for the most likely words. For instance, if top P is set to 0.1, only tokens comprising the top 10% probability will be considered. These are some variables that you can play with to control the way ChatGPT responds. Play with these variables in the dashboard so you can get familiar with them. You can also programmatically control ChatGPT's behavior using these variables by passing them as parameters to the ChatGPT API. More on this later. In the next few slides, I show some prompts and responses from ChatGPT. You can try these out by entering the prompt in the playground. Your responses are likely to be different from mine shown here because of the temperature setting. Question 1. Here's a question I posed to ChatGPT, somewhat thought-provoking you might say. See how ChatGPT tries to answer this. Question 2. Here's a follow-up question on the same subject. It asks ChatGPT to provide concrete examples of where AI is better than humans. Question 3. Here's another question posed to ChatGPT. It asks it to translate from English to French. LLMs are also capable of language translation. ChatGPT currently supports over 80 languages as of the time of this recording. This includes popular languages like Chinese, Spanish, English, and many others. Now here's a fun example, the restaurant waiter. It is a turn-by-turn conversation with a waiter in a restaurant. You can see how we provide ChatGPT with a minimum set of instructions for the waiter, You can see that as part of the system message. After this, ChatGPT is able to handle a conversation with the customer on its own. It greets the customer and lists the items in the menu. Then the customer makes an order for 2 bagels and a coffee. Since there are 2 types of coffee on the menu, ChatGPT wants the customer to specify which one they want. Here, the customer cuts ChatGPT short and asks it to generate a bill. Notice how ChatGPT politely asks the customer to confirm what type of coffee they want, because that's important for it to generate the bill. Now, the customer chooses an espresso. With this information, ChatGPT is able to generate the bill. Now, the customer is impatient. They ask how long it will take to get their order. Note again that ChatGPT replies politely and asks if the customer needs help with anything else. Modern LLMs have been programmed to reply to customers in a polite manner like this. Finally, ChatGPT prepares a bill and thanks the customer. In the real world, ChatGPT would probably direct this response to a printer to print this bill for the customer and instruct a billing system to take the payment. This is an example of how ChatGPT directs other agents to perform tasks that they are specialized to do. This is an emerging trend in the way LLMs are used, and they are called agentic workflows. We will cover this in a separate course. Prompting. In the last example where ChatGPT acted as a waiter at a restaurant, you would have noticed how it impressively handled turn-by-turn conversations with just one simple instruction provided as a system prompt. Programming ChatGPT to answer such customer questions is called prompting. Prompting is an art. How well ChatGPT responds depends a lot on how well you set the system prompt and how well you frame your question. Sometimes you may have to lead ChatGPT through a series of steps to answer the question. Here we discuss the various types of prompts. A system prompt provides initial instructions and context for the AI. A user prompt is the input provided by the user, and an assistant prompt is the response generated by the LLM based on the user prompt and the system guidelines. Essentially, the system prompt sets the rules, the user prompt asks the question, and the assistant prompt is the AI's answer. So here's an example. System prompt: you are a friendly and informative AI assistant. Always answer questions in a comprehensive and helpful manner. User prompt: what is the capital of USA? Assistant prompt: the capital of USA is Washington, D.C. Now let's look at a prompt for a customer service bot. Listed here is an example of a prompt given to ChatGPT as a system prompt. It instructs ChatGPT to play the role as a customer service agent. Notice here that there is a context that is being supplied to the LLM within the curly braces. You may be wondering what is in the context that is supplied here to the chatbot. That's where RAG comes in. We will get into RAG in a later module. Module 4, the ChatGPT API. In this module, let's look at a simple program to understand how the ChatGPT API works. Set up Python and pip in your machine if you have not already done so. This is described in the previous module on installation prerequisites. Copy the code from Git using the command line shown below. Store the API key in a .env file. Navigate to the ChatGPT with RAG course folder. Copy the API key created earlier in the OpenAI website and paste it into a file as follows. Name the file .env. This file and the key within it will be used by the Python program to communicate with ChatGPT API. Next, let's look at creating a virtual environment for the Hello World program. Navigate to the Hello World subfolder. Create a Python virtual environment. Here's a sample of how to create it on a Mac. If you want to look at more instructions on virtual environments, you can look at the link shown below. Next, you need to install the prerequisites and run Hello World. At this point, you should be inside the Hello World folder. Type the following on the command line: pip install -r requirements.txt, and then run the program using the command python space hello world.py. Attached here is an MP4 file that shows you the animation of how the Hello World program runs. You can follow along with the next few slides after you look at the animation, where we take a closer look at the code. Now here's a sample output from running the hello world.py program. It creates a short, witty poem on how to make pizza. When you run it, you're likely to get a different poem than the one shown here. ChatGPT and other LLMs have the ability to respond in different ways to the same question. And here's an explanation of the code behind what you saw just now. Notice how short the code is. The various lines of code perform the actions as described below. Lines 1 and 2 handle all the imports. Lines 3 and 4 is the code to pick the env variable or the environment variable, which is the API key, from the parent folder. Line 6 is where we create the OpenAI client. Line 8 is where we set up the system and user prompts. Notice that the system prompt says that you are a poetic assistant skilled in explaining complex cooking instructions with creative flair. Line 16 is where you collect the response from ChatGPT, and line 18 is where you print the response. So the crux of the code is in the lines shown here. First, you get the OpenAI client using the call to OpenAI. Then you get the completion by calling the create method on the client as shown here. In the completion method, you pass in the name of the model. In our case, it is ChatGPT 3.5 Turbo. You can try other models as well here. Then you pass in the messages, which is a list. Here, you specify the roles, such as the system role, the user role, and so on, and provide instructions on what each role should do. Finally, you get the response from the value returned in the completion variable as shown in the last line. Later on, I will show you how you can enhance this by keeping track of things like history, to handle turn-by-turn conversations, and so on. And finally, here are some exercises for you to try out. In the code that we have here, change the system and user prompt to something else that you like, or change the model to a higher or lower version. You can see the list of models from the OpenAI website. Module 5: Improving Prompts and Adding History. How can we add history? LLMs like ChatGPT will not retain the memory of prior interactions. The input to an LLM is always taken from the context window. So, if we need the LLM to remember the history of our conversation, we would need to supply it in the context window. But remember, the context window also has a limitation of how many words it can accommodate. This means we may need to use creative approaches to supply the relevant history so as not to exceed the size of the context window. We can do this by summarizing the previous conversations or sending only the last few conversations and so on. Here is an example with history that you can try out. It's called the coffee shop. In this example, we will see how we can add history so ChatGPT can remember previous conversations, improve the prompt so that it can serve as a waiter at the coffee shop. The example we will use is that of a coffee shop which serves coffee, donuts, and various breakfast items. First, create a virtual environment. Navigate to the coffee shop subfolder. Create a Python virtual environment. Shown here is a sample of how to create it on a Mac. If you want more instructions on virtual environments, you can look at the link that is shown here. Next, you install the prerequisites and run. You should now be inside the coffee shop folder. Type the command to install all the requirements using pip from the command line. That is pip install -r requirements.txt. Next, run the program using Python. That is python space coffeeshop.py. Shown here is a demo of the coffee shop application. You can click the MP4 file attached to this lesson to see the animation. It is called coffeeshop.mp4. Then you can come back to this presentation and follow along with the next few slides where we take a closer look at the code. Here is a sample output from the program. Shown in red are the customer's questions and responses. You can see how ChatGPT guides the customer through the order taking process. Here is some more sample output. You see how the AI agent completes the order and generates a JSON summary of the order. At this point, the order can be sent to other downstream systems for preparation and delivery. Next, let's dive into the code. In lines 1 through 4, we have the imports that you have seen before. We need these imports to run ChatGPT. In line 6, we get the response from ChatGPT by invoking the API. In line 18, we pass prompts to ChatGPT to capture history by appending past user and assistant prompts to the context. And in line 27, we print the order in JSON format, where we do this by changing the system prompt within this function. In line 46, we create the Open AI client. In line 48, we create the system prompt for a restaurant waiter. And in line 59, we initialize the context. Once the context is initialized, we go through an endless loop. First, we set the bot's initial greeting in line 63. And then within the endless loop in line 67, we handle the turn-by-turn conversation with the user. We capture the user prompt, we send it to ChatGPT, we get the response from ChatGPT, we print the response, and we exit when the user types buy or end. So how are we remembering history here? In the above function, notice how we append the prompt to the context of the user's role and the response to the context of the assistant's role. So we are basically appending all the history of the conversation, that is the user's prompts and the LLM's responses in the context. The LLM can use this information to provide a meaningful response. This is how it is able to handle the turn-by-turn conversation. This technique obviously has its limitations because of how much information we can pass in the context window. We will see ways to improve this in the next lecture. Module 6, Introducing RAG. RAG or RAG stands for Retrieval Augmented Generation. ChatGPT is an LLM that is trained on a vast corpus of public knowledge. One thing that it is not trained on is the knowledge specific to your business. For example, imagine a lawyer trying to ask ChatGPT about specific details from private case documents that ChatGPT does not know about. Or a customer asking ChatGPT about products that are available in an online store that ChatGPT is not trained on. How will ChatGPT be able to answer such questions? To help ChatGPT with such questions, you can augment the knowledge of the LLM with additional knowledge. This would come from a local database, a set of documents, the internet, or any external knowledge source. Before sending the question to the LLM, you will add more context to the question from these external sources and pass it on to the LLM. This will help the LLM provide the correct response. In short, this is known as RAG. Note that RAG is different from fine-tuning, in which the weights of the LLM are actually changed. RAG does not change the weights, and it does not perform any training of the LLM. So what are the benefits of RAG? RAG can help in overcoming the knowledge cutoff problem of LLMs. As you know, the LLM is trained on a vast corpus of public knowledge, and there is a cutoff date for the training. So it will not be able to tell you anything about what happened after the training date. This is because of the knowledge cutoff. The LLM can overcome the knowledge cutoff using the RAG architecture that we will discuss shortly. Next, RAG can help in augmenting the prompt with specific knowledge about your business that is something that your LLM is not trained on. Again, this is probably because the LLM is trained on public corpus of knowledge and your business has some private information that you want the LLM to be trained on. And finally, RAG architecture can prevent the LLM from hallucinating or guessing on an answer. Sometimes, when you have documents that will actually answer the question and you supply this to the LLM, you are actually helping the LLM to give the correct response rather than guessing on an answer. In addition, RAG will preserve the original weights of the LLM as we discussed earlier. Here is a picture of how the RAG architecture looks. The flow here is described as follows. First, the user queries the application. Next, the application takes the query and consults various knowledge sources to get more information. Next, the query, along with the enriched information from the knowledge sources, is sent to the LLM. The additional information is referred to as the context, which you saw in the earlier lecture. And finally, the LLM produces a response. This is returned to the user. Here is an example using RAG. Imagine that you're deploying this application to answer questions about products available in a retail store. Clearly, this information is not in public domain, so ChatGPT will have no knowledge of these products. In this scenario, we will supply the LLM with a database and product literature from our product catalog, as it is likely to have information that the user is asking, in this case, about shoes for mountain climbing. When an LLM receives this as part of its context window, it uses this information to provide the correct answer. One way that RAG models stores this information is in something called a vector store. We will look more closely at this shortly. Here, let us look closely at how RAG applications store documents. First, the documents are split into sentences and then into words. A sentence is broken down to words. Each word approximately represents one token. Sometimes a complex word might be represented as 2 tokens. These tokens are represented as vectors in an n-dimensional space, and they are known as word embeddings. Let us take a closer look at what embeddings are and how LLMs use embeddings to determine similarity between words. Shown here is a sentence: the driver drove the car. It consists of 4 words. Now the words are converted to tokens. The tokens are converted to embeddings. Now recall, an embedding is actually a vector in an n-dimensional space. And here we are using 3 dimensions just to illustrate the example. And you can see that the words car and driver appear close together, and the words country and capital appear close together as well. The angle between those words actually represents the distance, and that is what we term as the cosine distance. So if you have a sentence, the driver drove the, and then you have a blank, how will an LLM fill the most likely next word in this sentence? It is most likely going to be car, because car and driver appear close together in this example. Next, let us look closely at how documents are stored in the vector store. Recall that a vector store is basically a database that stores the vectors or the embeddings that we talked about earlier. First, the document is split into chunks, and then the chunks are split in such a way that there is some overlap between the chunks. This overlap helps the vector store to be able to track related chunks. Now, each chunk is split into embeddings, and then they are stored as vectors in the vector store. Module 7. Building a RAG chatbot. Alright, let's put all the theory that we have learned so far into action and build an application which demonstrates the power of RAG. The application is called the shoe rack. In this example, we will build a customer service chatbot for a shoe company called the shoe rack. The chatbot will answer customer queries on what kind of shoe to buy by recommending the most appropriate products from the store for the customer's question. If we had a generic chatbot based on ChatGPT for this task, it will not know anything about the specific products in the shoe rack. So, we need to make the chatbot know more about the products in the shoe rack. Fine-tuning or RAG. Once again, we discussed the 2 popular approaches that we alluded to earlier to supply knowledge to a chatbot. The first approach is fine-tuning. Here, we could fine-tune the chatbot by supplying more data about the products in the store, but this has some disadvantages. We need to keep fine-tuning the model as new products get introduced or old ones go obsolete. And fine-tuning will change the weights of the original LLM. This could lead to problems like catastrophic forgetting, where the bot forgets what it has learned before. And fine-tuning will take more time than other knowledge augmenting approaches. The second approach is RAG, or Retrieval Augmented Generation, which we saw earlier. We could use RAG to augment the resources for the chatbot. In this approach, we will supply the additional knowledge to the bot to make informed decisions to customer queries. So here we are going to demonstrate the use of RAG for this business scenario. The code for this example is inside the folder shoe rack. Inside the folder shoe rack, there is another folder called RAG sources. This contains the product collateral for the various products sold in the shoe rack. In other words, this is the knowledge base that the LLM is going to use. In our example, we build a vector store using embeddings created from the product manuals. Before we go into the example, let us talk about the tools used in this application. LangChain is a framework for developing applications powered by LLMs. LangChain provides a number of libraries which make it easy to load and process documents, connect with LLM APIs like ChatGPT, create embeddings and vector stores. This makes it ideal for building ChatGPT applications powered by RAG. LangChain also provides a library of functions to work with the Chroma vector store and OpenAI embeddings. In our example, we will use all of the above features. For more information on LangChain, including useful tutorials, please refer to the website for LangChain indicated here. Next, we create a virtual environment for ShoeRack. Navigate to the ShoeRack subfolder, create a Python virtual environment. Here is a sample of how to create it on a Mac. If you want more instructions on virtual environments, look at the link that is mentioned in this slide. Next, install the prerequisites and run the program. At this point, you should now be inside the ShoeRack folder. Install the requirements using pip, using the command shown here, which is pip install -r requirements.txt. Then, after the requirements are installed, run the program using Python as shown here, which is python shoerack.py. Here is a demo of the ShoeRack application. Click on the MP4 file attached to this lesson to see an animation. It is called shoerack.mp4. Then, after you complete the demo, you can follow along with the next few slides where we take a closer look at the code. Here is a sample interaction with the chatbot. The questions asked by the user are in the red boxes. Notice how the user begins by asking questions about what shoes to buy for his 10-year-old. And notice how ChatGPT handles the conversation and provides specific recommendations for the customer. In this case, shoes that are good for water sports. This slide shows a pictorial view of the application. First, you initialize the LLM, then you load the docs, and the docs are actually text documents in the RAG sources folder. Then you process the docs, which means you're splitting it into chunks and then creating the embeddings, and the embeddings are stored in the vector store. And then you create the retriever, and then from here you create a history-aware retriever, which is aware of the history of the conversation. And then you create the doc chain and then the RAG chain from the doc chain. And at this point, you are ready to take the user input. Now let's look at the code itself. In lines 1 through 4, we are doing the imports, the regular ones which we have seen before. And in lines 7 through 28 are the LangChain imports. And these are the imports that are needed for all the loading of the docs, the processing of the docs, the creation of the vector store, the embeddings, and so on. And then in lines 30 through 37, we are giving comments to explain what the app does. And notice that these comments are very much similar to the flow that you saw earlier, the pictorial view that you saw earlier. And then in lines 39 through 44, we have the global variables. You can actually experiment by changing the values and see how ChatGPT performs. In lines 46 onwards, we have a lot of functions that correspond to the comments in lines 30 through 37. Lines 169 onwards is where the vector store is initialized. And in line 187 through 205 is the main loop of the program. And in the main loop, we take in the user input, we check if it is the end, which is like when the user has typed buy or quit or end. If the user has typed one of these words, then we exit the program. But if not, we take that input and supply it to the LLM. We get the response, we print the response, and keep looping until the user exits. In lines 201 through 204, we have some comments. You can uncomment these lines if you want to see the documents that are actually matched from the vector store for each user question. Let's dive deeper into some of these functions. First, we have a line which initializes the LLM, and that is shown here. And notice we specify the model and the temperature as parameters to this function. Then we have the function to load the documents. This function loads the product documents that are present in the RAG sources folder, and they are of type .txt. You can see that I use a text loader function supplied by LangChain to help load these documents. The function creates a list of documents and returns it to the caller. Next is the function that chunks and splits the documents. You may recall that we discussed chunking and splitting in an earlier lecture. This function helps in splitting the documents into smaller chunks. Each chunk has a size of 1000 characters and an overlap of 200 characters. This function creates a vector store from the chunks. It uses the built-in Chroma vector store, which is an in-memory vector store. It also uses the OpenAI embeddings function provided by LangChain to create the embeddings from the document splits. This function creates a retriever to fetch the best matches from the vector store. Notice that it is set to fetch the top 10 relevant matches, where k is the parameter supplied and k equals to 10. This function uses LangChain's built-in function to create a history-aware retriever. Instead of storing the entire history, which we did earlier in the coffee shop example, and which can occupy a lot of memory, this function recreates the context each time with a new question that can be understood without the chat history. And this function creates the document chain. And the key point here is the system template. You are a customer assistant who can answer questions about products in the shoe rack, a large online store selling shoes and sandals for men, women, and children. And then you have a context that is being supplied. Now, notice that this is where you would embed the documents that are fetched from the vector store. So if you put all these together, this is how it looks. First, the user asks a question, and in this case, it's a question that where the user is asking for a good pair of shoes for mountain climbing. The orchestrator goes and pulls the relevant documents for mountain climbing from the vector store, and then it enriches the user's question with the knowledge that it has obtained from those documents and supplies it to the LLM. And the LLM uses the enriched information to come up with an output. As you probably noticed, the LLM does not always respond in the same way or provide us with all the information we need. We sometimes have to ask the LLM multiple questions to get the same answer. And sometimes it says, "I'm sorry, I don't know. Would you like to speak to an agent?" So obviously, these are areas that can be improved. And we discuss some of those improvements in the next slide. So how can we improve the performance of the LLM? First, we could add more product manuals inside the RAG sources folder. So we could supply more details about products available and classify them into different categories and help the LLM choose the right category for the customer's question. Or we could modify the system prompt to provide more hints and suggestions to the LLM on how to answer a question. Or we could change the top k value. Recall that in our code we used k equal to 10, but we could change k to a bigger or a lesser value so that we can retrieve more or fewer documents from the knowledge source. We could change the model. In this case, we have the model set to GPT 4-0, and there are newer models coming up all the time, and LangChain provides options to integrate with other model providers as well besides ChatGPT. We can change the temperature setting. The setting of the temperature to 0 will make the model produce the same values every time, and setting it somewhat higher will produce increasingly random results. Now let's take a step back and think on how ChatGPT would have responded without RAG. To try this, disconnect the RAG and ask the same question to the model, and you will see how it responds. You can also check on how it would respond if you change from the Chroma vector store to another one. And LangChain provides various options to integrate with other popular vector store vendors as well. And finally, you can have the bot complete the purchase or check on a previous order from the customer. This is done by what we call as an agent workflow, which we will cover in another course. Before we close this lesson, there are a few more things that I would like to discuss. What we saw here was just a toy example. In the real world, you will need to follow several procedures to ensure that the LLM is performing well. The first of these that we need to worry about or think about is building safeguards. Here are some steps that you can follow to build the right safeguards. First, you have to define metrics for factual accuracy, toxicity, and bias. You monitor the LLM's outputs on these metrics, and then you establish guardrails to keep the LLM to answer strictly from the sources provided. You check the data sources for any bias and make sure that the data sources are a fair representation of the real world. For scenarios where precise answers are required, you can keep the temperature setting low. And finally, you have to make sure that the LLM's responses are compliant with the regulatory compliance procedures that are applicable to your industry. Next, let's talk about monitoring system performance. In a real-world application, you will need to set up various performance metrics to monitor the application. Some of these metrics are latency, throughput, error rate, drift, and so on. Cloud providers such as AWS, Azure, GCP, and others provide real-time monitoring tools to observe and report on these metrics. Take, for example, the drift that I have mentioned here. What would happen when you introduce new products in the store or you expire old products and your sources folder or the knowledge base is not up to date with that information? Clearly, this is a scenario of drift where the LLM would start providing wrong answers to the user's questions. So to avoid this drift, you have to make sure that your knowledge base is up to date all the time. Finally, let's talk about privacy and security. Customer privacy and security are very important issues in many real-world applications. For example, you may need to ensure that the data shared by the customer in the chat are not used by the LLM vendor for improving the performance of their model. Now, this does not happen automatically, and you have to change a setting in order to do so. To prevent ChatGPT from using your data, navigate to your account settings, go to data controls, and toggle the option that says improve the model for everyone. This essentially opts you out of allowing ChatGPT to use your conversations for further training its model. Other vendors have similar solutions that allow you to opt out of data collection for telemetry. Another approach is to have your own model served from your own cloud or your own on-premise servers instead of relying on the model supplied by the vendor. Another scenario that you should monitor very closely is the situation where the LLM could go rogue. For example, your chatbot must not trick the user into revealing personal details beyond what is needed. You will have to build adequate safeguards in the application to prevent this from happening. Module 8 Conclusion. What did we learn? In this short course, I introduced you to ChatGPT and how LLMs work, the ChatGPT API, and the programmatic way of communicating with ChatGPT, building apps using the ChatGPT API and Python, the RAG style architecture, and building RAG enabled ChatGPT apps using Python and LangChain. The RAG based approach that we discussed here is one of the most powerful ways of expanding the capabilities of LLMs. It can be applied immediately to a variety of business situations, as can be seen in the next few slides. The first of these is call deflection. LLMs can help in customer service functions by deflecting customer calls from human agents to automated systems. As can be seen in this example, AI agents can handle most of the routine calls, while human agents can be involved only in answering the more complex calls. Think of the money saved by call centers. Another useful business case for RAG is to function as an expert assistant. For example, a lawyer could use such an assistant to answer questions from past legal cases. A doctor could use such an assistant to pull up references from medical journals. A teacher could use such an assistant to help answering questions in history, literature, finance, mathematics, and so on. The applications for an expert assistant are endless. More areas to explore. For those who are interested in going further with chatbots and AI, here are some interesting areas to explore. Look out for my courses on these topics. The first one is AI agents and workflows, and the second one is the multimodal and multilingual conversations. AI agents can help a chatbot in performing specialized tasks such as doing complex calculations, completing payments, making online bookings, and so on. With the help of such agents, a chatbot can perform complex end-to-end tasks that only humans can do. So shown here is an example where a customer is planning a vacation. The AI chatbot has an intelligent conversation with the customer and considers various options for the trip. Finally, it interacts with various agents in the back to book a flight, to book a hotel, to book a car, and to collect the payment. Another interesting use case is multimodal apps and multilingual conversations. LLMs can perform tasks like interpreting what's in a picture, generating a picture or videos from text, translating text from one language to another, and so on. These capabilities can be used to build interesting business applications. Shown in the top is an application which takes a user script and generates a movie from it. And shown below that is an application which handles conversations between two users, one of whom speaks in English and the other speaks in Hindi. The agent sits in the middle to translate the English responses from user 1 to Hindi and the Hindi responses from user 2 to English. So this is another very useful application that can be built using ChatGPT. And with that, we come to the end of this course. A big thank you to all who came along with me on this journey. I hope all of you enjoyed this course as much as I enjoyed teaching it. And be on the lookout for more courses from me. Thank you once again. Congratulations on making it to the end of this course. Here's a small bonus lecture for you. Finally, a little about my company, Connected World. We are involved in providing training, software development, and consulting in the field of artificial intelligence and machine learning. If you're interested in our products and services, please visit our website provided here or drop in an email to the address provided here and we will be happy to discuss your project with you. Once again, thank you for listening and all the best in your artificial intelligence journey.